In this video, we're going to be talking about solving quadratic equations using the quadratic formula. So one of the great things about the quadratic formula is that it works with every single quadratic equation. So sometimes when we're solving, we can try factoring or the square root method, but those only work some of the time, whereas the quadratic formula works every time. So if we are given an equation in standard form, ax squared plus bx plus c is equal to 0, we can use this formula right here to solve for x. So let's take a look at an example to see what that looks like. So in this first example, they want us to solve the equation 2x squared minus 5x is equal to -3. Before we can use the quadratic formula, we need to get our equation into standard form. That's always going to be step 1. So that means we're going to add 3 to both sides so that it's equal to 0. So we get 2x squared minus 5x minus 3 is equal to 0. Now we're going to take this equation in standard form and we're going to identify our a, b, and c values so that we can substitute those into our equation. And this is the equation that we are talking about. So a is 2, b is -5, and c is -3. So the first thing that we're going to do is we are going to substitute each of those into our equation. And I like to put parentheses around everything just to make sure that I don't accidentally multiply something incorrectly. So we get x equals -5 plus and minus the square root of -5 squared minus 4 times 2 times -3, all divided by 2 times 2. So you can see that I substituted b -5 everywhere we saw a b. I substituted 2 everywhere we saw an a, and -3 everywhere we saw a c. So the hardest part about this is simplifying it correctly using order of operations. So something to keep in mind, one of these big subtraction bars is really like a super big grouping symbol. It says do the top stuff, do the bottom stuff, and then you're going to end up dividing. And then within the top, there's stuff that we need to do first. So the part that we're going to start with is this part right here underneath the square root. So I'm actually going to show you how to type that part into your calculator to make sure that you're doing it correctly. Basically, as long as you're typing it exactly how you see it, then it should be good. So we're going to type this part into our calculator, the part underneath the square root. So I'm going to type it exactly how I see it. So -5 squared minus 4 times 2 times -3. I'm going to type it exactly like that, and it's going to tell me that we have 49. So now I'm going to replace that all right here in our problem. So, and I'm going to simplify some other things as I go. So really that's -1 times -5 is really +5. Plus and minus the square root of 49 divided by, I can do 2 times 2, which is 4. So we get to this point right here. Well, you'll notice that we have a plus and a minus. That means that we're actually going to have 2 solutions, which makes sense because we've already seen that when we solve by factoring or by square rooting, we have the possibility of 2 solutions. And when we take the square root, we always get a plus and a minus. So I'm actually going to split this into 2 different problems. I'm going to say x equals 5 plus the square root of 49 and over 4, and x equals 5 minus the square root of 49 over 4. I'm going to scoot down a little bit. So we also know then at this point that we are going to simplify each of these. So the square root of 49 is really 7. So this really says 5 plus 7 over 4. And this one says 5 minus 7 over 4. Again, order of operations matters here. We have to do the whole top before we do the denominator. So 5 plus 7 is 12 over 4. 5 minus 7 is -2 over 4. So if I were to simplify each of these, we are going to end up with 12 divided by 4 is 3. And -2 over 4 is a -1/2. So these are the 2 answers. You can't really read that. These are the 2 answers that would make our equation true if I were to substitute these back in to our original equation. So we're going to look at some more examples about what might happen. So really quickly, actually, let's talk about what this would mean on a graph. If I were to get these two solutions, that means that when I graph this equation right here, when I graph y equals, I'm going to end up with an x-intercept at 4 and an x-intercept at -1/2. And then when we connect these, it'll look a little something like this. But we know because there are two solutions here that we're going to end up having two x-intercepts as well. So we just wanted to make the connection back to the graph really quickly because we're going to look at some more possibilities. So let's look at another example. So in this example, they asked us to solve 2x squared plus 4 equals -3x. So step one was getting it into standard form by adding 3x over. Be careful that you put it in the right order. Remember, bx has to go in the middle. I identified a, b, and c and substituted those values in, and I started simplifying the part underneath the square root, and I got to here. Well, if I try to type in the square root of -23 into my calculator, it's going to tell me that there are no real solutions. So I can stop right here and say, well, because I can't take the square root of a negative number, there are no real solutions to this equation. I can't actually solve this. So what that would look like on a graph would be that I have no x-intercepts because we know that solutions are really x-intercepts because we're solving for when y is 0, essentially. And since this one is never on the axis, the x-axis, it kind of looks something like this. That's not a great drawing, but we're going to go with it. It never touches the x-axis. So no real solutions also means that we have no x-intercepts. So we're going to look at one more possibility that we see with the quadratic formula. So in this example, they asked us to solve -18x plus 9x squared plus 9 equals 0. First thing I did was put it in order, so now it's in standard form. And I noticed that all of these are divisible by 9. So I can actually divide by the GCF of 9 on both sides, and I end up with this equation. If you don't do this, you'll still get the same answer. It's just you're going to have bigger numbers when you're dealing with it down here, which is fine with a calculator, but if you don't have one, it makes it a little bit more difficult. So I identified a, b, and c. I substituted those in, and then when I did that, I got to this point right here. Well, here's the really important part. When we take the square root of 0, we end up just getting 0. So I end up with 2 plus or minus 0 over 2. So if I split this into my two possibilities because of the plus and minus sign, we would get x equals 2 plus 0 divided by 2, and x equals 2 minus 0 divided by 2. Again, we have to do the numerator first. So we get x equals 2 plus 0 is just 2, and so is 2 minus 0. So all of a sudden, we end up, that's a 2, you can't read that. We end up with the same answer twice. So if I scoot this over to show you, we really end up with x equals 1 and x equals 1. So we get the same answer 2 times, and that happens when we have this 0 underneath the square root. So in this case, when we see x equals 1, that means that on a graph, I'm only going to have one x-intercept. Well, the only way for that to actually happen is if it just hits on the x-axis at 1 time. So it's going to end up looking like that. So it only touches the x-axis once. So those are the 3 possibilities that we can get when solving equations using the quadratic formula, or really solving quadratic equations in general. So these would be the types of solutions we can have when solving quadratics. 2 real solutions would have 2 x-intercepts, 1 real solution has 1 x-intercept, and no real solutions has no x-intercepts. When solving with the quadratic formula, 1 real solution happens when the number under the square root is equal to 0. And no real solutions happen when the number under the square root is negative. 2 real solutions just happens anytime we're taking the square root of a positive number, because we know that when we take a square root, we always get a plus and a minus. So number under the square root is positive. So that pretty much wraps up what we need to know about the quadratic formula.